So now we move on. So you guys have learned how to resolve forces. So you've got forces in 2D. So now the next logical step is to analyze forces in 3D. So when you have forces in 2D, you have two axes. You've got X and you've got Y. So when you move on to 3D, you add one more axis. However, when you want to draw, you have to draw something like this. So typically, Y and X axis is drawn this way, typically, but not all the time. All this depends on the question, depends on the analyzer. How do you want to analyze it? You can draw it any other way, but typically people will draw in this direction. So you can use your hand as a reference to make all the axes. This is X, this is Y, going up is Z. This is one of the reference that you can use. And of course, you're gonna have negative X at the back here. This one is negative X. This one is negative Y. And going down, it's a negative Z. So these are the axes that you have to consider. Alright, so take a look. Let's make things clearer a bit more. We are now looking at, let's use this one. Erase all ink in one slide. Okay, so let's look at this one. So you've got, this is your x-axis, X. This is y-axis, and going up is your z-axis. So when you want to draw your axis, your force, which is in 3D, you have to draw in this condition. So what this coordinate system does, it is using actually a rectangular to define the force direction. So if you take a look, it's basically one rectangular. The force that you are defining is actually coming from the origin and goes to this edge. This is your X, this is your Y, this going up is your Z. These are all your axes. So this length is actually Fx. This one, this length is actually Fx. This length on the y-axis is actually Fy. And finally, this whole length, this long length, is actually Fz. So that's how you defined it. Let's say you've got a value, let's say this one. Let's say this one is 100 I. This y-axis is 100 J. Let's say the top one is actually 141.4 Z. So you've got a total, this one, 100 I, 100 J, positive 141.4 K. You can find the magnitude by using this formula. Fx squared plus Fy squared plus Fz squared, square root the whole thing. You gotta square root the whole thing. You're gonna get back the original value, 200 Newton. So let's say this one, this guy is basically Fr. Let's say the value here is 200 Newton. You can resolve it using this relationship. And this one is basically a rectangular, using a rectangular coordinate system. So you still have all your components lah, I, J and K. So other than looking at the rectangular, you can also resolve their direction. So again, we are using vector, right? Vector, you're going to have magnitude, and you're going to have direction. So since you already have magnitude, you need to also define the direction. One of the ways to define the direction is using all these angles. If your axis is starting from X, you can call this alpha. When your axis is defined to Y axis, we're going to call this beta. And finally, to the Z axis, we're going to call this gamma. So you have alpha, beta, and gamma. So these are something called coordinate angles. You've got alpha. What are these angles to? The angles from force. This is your force. This is your X axis. This is your Y axis. This is your Z axis. So these are the force angles. So how do you define these angles? You have to look at it properly lah. You have to look at the planes. These are actually making planes. If you look at this particular plane, you're going to have this one. Therefore, you can use cos. I think it's clearer if you look here. So you've got, in order to get all the angles, you have, it's almost similar as what you have previously lah. What do you have previously? Fx is equal to f r cos. Previously you learned this one, right? You learned fr cos theta. So now fx is actually fr cos alpha. So fy is actually fr cos beta. And fz is actually fr cos gamma. So coming from this, you can get all the angles. So we are looking at each individual plane's angle. So let's say you are looking at beta. So you're going to get something like this. This is your beta. This is your hypotenuse, or your FR. This is your FY. So cos beta is equal to Fy over hypotenuse, which is your FR. So you can look at it that way. Other than that, coordinate angles, which is your alpha, beta, and gamma. So this is gamma. It is also governed by this formula or identities, which is cos squared alpha plus cos squared beta plus cos squared gamma is equivalent to 1. And this is the magnitude. So this is some sort of identity, trigonometric identity. So the value, if we were to expand the values inside, you're going to get something like this. And when you convert to vector, you have another value lah, which is I, j, and additional k. Okay. So might not be so clear for you now. We have to do exercises in order to understand. So let's look at this one. This is 200 Newton. You have, this is the force, 200 Newton. This is actually y-axis. So y-axis, we're going to call this one beta. This is to the z-axis, we're going to call this gamma. We're going to call this angle as gamma. However, alpha, we don't know. We do not know the angle alpha. In order to solve alpha, you have to use this identity. Use this one. So this is the identity that you are using actually. So cos squared alpha, you don't know. Just follow through. Cos squared alpha. Beta, you have 60 degrees. And gamma, you have 45 degrees. So since this one you don't know, let's continue and do the calculation here. So the value that we are stopping now is cos squared alpha plus cos squared 60. What do you get when you cos 60? Press your calculator. Cos 60. It is actually 0.5. So square it. Cos 45, 0.7071 squared is equal to 1. So that's the value that you get lah. So if you rearrange it, you're gonna bring all this to the other side, right? When you bring those to the other side, you're gonna get something like this lah. Cos squared alpha, you're gonna have equal to 1 minus 0.5 squared. What do you get? 0.5 squared. 0.25. It's going to be minus lah. This one also another minus. 0.7071 squared. 0.5. So in order to solve this squared, you have to square root. And not only square root, you have to square root on both sides. So this square is gone lah. So you're gonna see cos alpha. And this value, since it's a square root, you're gonna get a plus and minus 0.5. Why? Since it's a square root. So it can be a positive value, it can be a negative value. In order to decide which one is what, you have to look at the angle. So if you are using positive, which is the top one, right? Look at this one. This one is assuming positive. You get 60 degrees. If you are assuming a negative, you're going to get 120 degrees. So in order to choose which one is the correct one, is it the first one or the second one? There is no other way. You just have to look at the problem. So what do? Look at problem. So look at the problem. Let's look at the problem. The angle that you're supposed to see is most likely from the top. So just imagine this is you, your eyes. You're looking down, 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 down. So what do you see? You need to convert it into D. If you convert all these things into D, you're gonna get this one. Y-axis. This one is definitely going to be X-axis. Where is your Z-axis? Z-axis is actually here. That is your Z-axis. So now, draw your force. Your force is going to be like that. This is your 200 Newton. Now, draw your angle alpha. Looking from the top, you're gonna get something like this. So notice, I do not draw the angle nicely like this, right? It's not nicely like this. It's actually slanted a bit. This one, slanted a bit. So when you're looking at alpha, you're basically looking at this alpha. So this alpha, it's not more than 90 degrees. Alpha is less than 90 degrees. So it cannot be 120. 120 is wrong. So you have to choose 60 degrees. No choice. So 60 degrees is your angle. So how to decide this one? There's no other way. You have to draw in 2D using the eyes method. Okay, you have to use your eyes. So once you've got all the angle, it's very easy to convert. You have to use this equation, which is f cos alpha plus f cos beta and f cos gamma. So when you are using this, it will automatically decide for you the negative. So it will automatically decide for you the negative and positive value. For example, you just have to key in. Let's say you have currently your alpha is 60 degrees, right? So when you have this one, remember, cos 60 degrees. So cos 60 degrees is equivalent to positive 0.5. If you have something in the more than 90 degrees, which is cos 120, press your calculator, you're going to get a negative value, negative 0.5. So let's say your alpha here is 120 degrees. So you are going to be on the other side already, on that side. Meaning, this one, you're going to be over here. Let's say your alpha is 120. So this one, this value, will automatically be negative. So you just have to stick to everything is positive. When you key in 120, it's automatically going to be negative 100i plus all this thing plus 141.4k. So that's how you do it. So you might want to test it again, do all this thing again, or we can move on to the next question. So there are plenty of questions to look at in 3D. You've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, 9 probably. So let's do. Let's solve this problem 2-61. This problem is also available in your tutorial. You can look at the tutorial. Okay, so you've got two force. One force is this one, which is obviously in 3D format. And one force is this one, 3 kilonewton. This one is actually in 2D format. So one of the method is for you to do is you have to find resultant. In order to find resultant, you need to find F1, but in I, J, K plus F2, but in I, J, K format. Then you're going to get the answer. So the challenge is for you to convert everything into vector. So now let's do it. Let's do it for F1 first. Seems like F1 is pretty easy. So let's do it for F1. We are looking at F1 first. So F1, if you look at F1 and you convert them into vector, you're going to see something like this. This is your axis. This is axis X. This is actually Z. This is your force. What is the value? 3 kilonewton. What is the gradient? Draw your gradients. Your gradients are here. 3, 4, hypotenuse is 5. So, it looks like it's in 3D. Yes, it's in 3D lah, but basically it boils down to 2D. So converting this one is something we have done before. Okay, so F1 is equivalent to what? F1 is actually going this way. So you've got 3. This one is hypotenuse, which is I plus 3 over hypotenuse. This is not J, it's actually K. Now look at horizontal. This is horizontal. So you put in the values lah. Horizontal is this one, 4 over 5. How about this one? Look at the vertical component. Vertical component is 3. So this one is actually 3 over 5. So if you notice, probably you haven't noticed this yet, but if you notice, if you look at this triangle, let's say this is theta, right? This is theta. So this value is 4 lah. This value is 3. This value is 5. What is cos theta? Cos theta. Cos theta is actually 4 over 5. And what is sin theta? Sin theta is actually 3 over 5. If you really take a look at it, cos theta is actually 4 over 5. So this 4 over 5 is actually you are writing 3 cos theta I plus 3 sin theta K. You are replacing the cos and sin that you have learned in 2D by using this ratio format. So basically you're still doing the same thing. Okay. So let's continue and write them properly. So this one you're gonna get, what do we get from here? Punch in your calculator. 4 over 5 times 3. It's actually 2.4i. This one is actually 1.8K. This is F1 in a vector format. So this one is very important. Rectangle it. Rectangle all the things you're going to use again. So this is F1. Now let's continue and to do F2. Now let's do F2. Let's look at F2. In order to find F2, so look at all your axes. This is X. This is Y. Where is Z? This is Z. So this one is actually alpha because it is in reference to X-axis. This one is actually reference to Z-axis. So this one is actually gamma. Okay, this is gamma because you are referring to Z-axis. And finally, this would be beta. And beta we don't know. So there is only one way to find beta value. That is to use this identity, which is cos squared alpha plus cos squared beta plus cos squared gamma is equivalent to 1. You have to use this identity. Where do this come from? This comes from your rectangular coordinate system. This formula is valid for rectangular. So all your, remember the one that you learn in 3D, it's actually you are using a rectangular coordinate system. Your force is actually from origin until this very edge. Since this one is X, this one is Y, this one is Z, this one is alpha, this one beta, and this one gamma. So that's the thing. This is where this formula is coming from. So you can use this as your reference. So alpha we know, so write down cos squared 60 degrees. Cos squared beta you don't know. Cos squared gamma 120 degrees equals 1. Let's write down cos 60 0.5 So write down 0.5 squared. This one don't know. This one cos 120. Cos 120 you're gonna get negative 0.5. Since you are squaring it, so there's no difference lah. 0.5 negative 0.5 squared. Negative 0.5 times negative 0.5. You'll definitely get a positive value. So you don't have to worry about this lah. 0.5 squared. 0.25 0.25 plus beta plus 0.25 equals 1. So cos squared beta is equivalent to 1 minus 0.25 minus 0.25. You're going to get 0.5. Okay. So now you have to square root on both sides. Square root this side, square root also this side. So beta is equivalent to square root 0.5 plus minus 0.70. Really, correct. 0.7071. What do we do now? This is actually cos beta, right? Cos beta. We haven't get to beta yet, so we gotta get to beta. I'm gonna have to clear this up. We haven't solved this one. So beta will be two things. Cos negative 1 positive 0.7071 or cos negative 1 negative 0.7071. This one, what is the angle? This one, what is the angle? Shift cos 0.7071. You're gonna get you're gonna get 45 degrees. 0.7071 negative 0.7071 shift cos or 135 degrees. Which one is it? How do you decide which one? Is it 45 or 135? You have to look back at this problem lah. So look back here. Where is your beta? Beta is here, right? Beta is very small. This one cannot be 135. 135 is wrong. It is not 135. Since it's not 135, it's definitely 45 degrees. So there you go lah. It has to be this one. 45 degrees. So now F2 is very easy. F2 is actually 2 cos alpha. Alpha kah? Alpha I plus 2 cos beta J plus 2 cos gamma K. Everything is plus plus plus. Everything is cos cos cos. There is no sign. So now we plug in. Dua cos 60i. 2 cos 45j 2 cos gamma 120. So there you go. 2 cos 60. So you have I only plus 1.414. This one will automatically give you negative k. Why negative? You try key in cos 120. This one will give you negative 0.5. So it will automatically put you in the negative region. So this is your F2. And you know that F2 is very important. So you have to rectangle the important things. So now you got to do the summation lah. Summation, which is F1 plus F2. So summation would be, how do we do this? Summation would be F1 plus F2 lah. So equivalent to 2.4 plus I. So you're gonna get 3.4 I. 1.8 plus, I gotta write down properly. Let's write down properly. This one I have to remove. Make sure you write down in your notebook. Let's leave this one. Let's leave one reference. What is it? 45. What is this? Let's leave one now for your reference. Okay, let's do the summation. F1 plus F2 is 2.4 I plus 1.8 K plus I plus 1.414 J minus K. So what do you get? So you have to solve part by part lah. Solve I with I. So what do you get? 3.4 I. J, there's no other J. So 1.414 J. Finally K. So plus 0.8 K. This is your F resultant. Definitely you need to look at the magnitude. So what will the magnitude be? The magnitude would be down here. Using this formula. What formula is that? F resultant square root x squared fy squared plus fz squared. There you go. And plug in lah. 3.4 squared plus 1.414 squared plus 0.8 squared. Remember, you have to do the whole square root. Whole square root. So what is the value? You're gonna get 3.768 kilonewton. So there you go. This is how you do it. But then again, we are not quite complete. Not quite complete. We need to find something called new angles. Then we are perfectly complete. You need to find new angles. So new angles alpha. What is the value be? New angle alpha. Cos -1 fx over fr. There you go. If you do this, when we are complete lah. So you have to look at this one. So cos -1 fx 3.4 divided by 3.768. So get the value. After that, beta cos -1 fy over fr cos -1 fy, this one lah, 1.414 over 3.768. Get the value. And finally, new gamma cos -1 fz over fr. What is the value of fz? This one. If it's a negative value, put a negative value lah. So this one is fortunately positive value. So if you can do that, find out what are these values, what are the new angles, new angles, new angles. Even better if you can draw the new axis. This one plus this one. Probably the resultant will be somewhere here. FR. Right, you can do a simple parallelogram. This is your FR. The new coordinate angle. This is the new alpha. This is the new beta. This is the new gamma. That's the thing. Then we are complete. Right? Everything is okay. Only one thing left out from here is nothing is left out. Beta is here. Okay. Easy or hard? This is how you do it in 3D. Next question. Have a gander at this first. How many force do we have? One force. Express the force as a Cartesian vector. How many problems do we have left? There's a lot now. So, something like this. What are you going to do? Don't look at the answer yet. You have to understand how to do this. In order to do this,